All right, we are doing a very quick review of exponent rules, looking at a number of different rules in this quick review. Okay, product rule is first. Our bases are the same. We're going to take the exponents and add them. Power rule, we have just one base and it's raised to 2 powers. So basically a to the b power. You're going to multiply those but keep the same base. Quotient rule, you have 2 bases that are the same and you're doing subtracting exponents top minus bottom. So let's apply all of those to our next 4 examples. Here we have 2 bases, they're being multiplied, that's product rule, so we're adding. So 2 plus 3 is going to give me x to the 5th. The next one, we have just one base, but power to a power. So when you have power to a power, you're multiplying. So 2 times 3 is going to give me x to the 6th. The next one, we're dividing, so we are going to subtract. That's going to be 5 minus 2. That's going to be x to the 3rd. Here, also dividing, and we're subtracting, but we're not going to do 5 minus 2 here. We're doing top minus bottom. So 2 minus 5 gives me negative 3. And you can get negative exponents. That's okay. And that is the correct answer for that one. So let's talk more about these negative exponents. If you have a negative exponent and I want to make it positive, that means you're bringing it down to the denominator and taking off the negative. So we're basically making it a fraction. And conversely, if we have a fraction with a negative in the denominator, you're going to bring it up to the top and make it not a fraction. And that negative comes off to just make it x to the b. Okay, so let's simplify the following by just writing them as positive exponents only. So if we have x to the negative 7, a negative crosses the fraction bar with that expression. So we're going to make this be in the denominator now, but with a positive, which means on top you're putting a 1. Okay, we just need to basically a placeholder there. Next one, this is a negative in the denominator. To make it positive, we got to take it across the fraction bar and make it positive in the numerator. So this is going to be x in the numerator to the 12th. We took off the negative and we don't need the fraction anymore. This one, we've got to do quotient rule first. So we are subtracting x to the 7th divided by x to the 9th is going to be 7 minus 9, which is x to the negative 2, which simplifying that allows me to take it back down to the denominator, x squared with a 1 on top. Okay, and then the last one, this is power rule. So we have the base raised to a power. So this is going to be x to the negative 16, but I don't want it to stay negative. So we're going to take it to the denominator, make it positive, and put a 1 on top. Okay, so that's some very basic exponent rules. Great chance to review those. Let's look at a little bit more intense exponent rules here, and this is when we're converting radicals to rational exponents. You may not even know that's possible, but you can do that. And if you're going into calculus or maybe a future math class, you may be doing this more often, okay? This happens a lot in calculus though. Converting radicals to rational exponents, you have, let's say, an exponent or a radical expression, that is the b root of x to the a, okay? A lot of times we'll say the 3rd root or the square root or the 5th root, okay? The way you're going to convert this is you're going to keep that base as the base, and then this a and b, the inside exponent is going to be the numerator of a fractional exponent, okay? So fraction means rational. Rational means fraction. Okay, and we're going to divide by the index. So this little b is called the index. So we've got the exponent on the inside divided by the index. So let's practice that. Here we have our base of x. The inside exponent is 4, and we're going to divide that by the index of 3. So this would be x to the 4/3. So you would end up with a fraction up in the exponent for the answer. Let's look at the next one. We've got the square root of x to the 7th. Base is x. What is my exponent for that x? It's going to be 7, so that's going to be in the numerator of a fraction. But this is a square root. We don't have a number there. So what is understood to be there? Square root implies a 2. So this is going to be 7/2. Looking at our next one, we have a base of x. What's its exponent? We can't see it, but there is one. It's a 1. Okay, and then what is its index? It's 2 because it's square root. So this will be x to the 1/2. This one's used so much, okay? So definitely commit that one to memory. All right, and then what's the base here? Oh, this one's a little trickier because we have an expression underneath this. So you cannot treat this the same way. What I want you to think about here is this is really x squared plus 3 to the first. Okay, I apologize for my pen, but here we go. This is going to be x squared plus 3 to the first. So everything that's underneath there is going to stay. X squared plus 3, that's going to stay. Its understood exponent of 1 will be in the numerator of the exponent. We're going to turn this into the fraction just like we did the other 3. So what is my index? That's that understood 2. And that is okay too. You can write and change it, that expression, to x squared plus 3 to the 1/2. That's okay. All right, this next one's saying simplify the following by converting to rational exponents. And then we want to write all answers with expressions in the numerator. So instead of getting rid of the negative, we want to make everything in the top, in the numerator. Okay, so let's see if we can figure this out. All right, converting this one to first be 1 over, how are we going to convert this square root of x? Well, we just did square root of x right there. It is x to the 1/2. But if I want this to be in the numerator, I've got to bring this up to the top. And when you cross the numerator, when you cross the fraction bar, you're going to take off or add. Basically, it's going to do the opposite sign for the exponent. So if this is a positive 1/2 in denominator, it's going to be a negative 1/2 in the numerator. Okay, now, I don't really need anything in the denominator. It's just over 1. So this is just going to be x to the negative 1/2. You're going to see that a ton if you go into future math. All right, let's look at this one. I think we probably need to convert this part first. So this inside part is x to the inside over outside. So 5 divided by 3. But that's all raised to the negative 1. Okay, what rule is this? Power to a power. That's going to be multiply. So 5/3 times negative 1 is x to the negative 5/3. Can you have a negative? Yes, you can totally do that. So my answer here would be x to the negative 5/3. Next one, got a couple steps here. First, we're going to do the inside. So this would be 1 over something to the negative 2. Let's figure out that something. This is square root of x. So again, we're back to this. That's going to be x to the 1/2 equals 1 over x. This is power to a power. What is 1/2 times negative 2? Use your calculator if you need to. 1/2 times negative 2, 1/2, I'm going to do it over here. 1/2 times negative 2 over 1 is negative 2 over 2, which is simply negative 1. But if I want this in the numerator, I'm now taking that x to the negative 1 and moving it up. Okay, so now I've just got x to the first, and I don't need it over 1, and x to the first is just x. Okay, so a lot of work there, but it simplified a lot. We like that. Let's look at our last one here. We've got y squared, and let's simplify this bottom here. So we've got x. Our inside exponent is 9, and we're dividing by the index of 2, but we want everything in the numerator. So this is going to be y squared. How do I bring this x to the 9/2 up? I have to change the exponent sign. So this is going to be x to the 9/2, but negative. And that would be the final answer on that one. Okay, so definitely practice that. Basically, we want you to know how to convert radicals into an expression with a rational exponent and consider all the negative signs to that. Now we're going to take it a step further. I want you to first simplify each one of these terms where it's an expression with a radical exponent, and then we're going to use our factoring that we've learned to factor out the greatest common factor. Okay, so first we're converting. So x to the 4, or fifth, sorry, let me start over. Fifth root of x to the 4th is going to be x inside over outside, so 4 over 5 plus x inside over outside, 11 over 5. Move this up a little bit and see if this helps. Okay, so we have x to the 4/5 plus x to the 11/5. Do you notice that both of these exponents have a denominator of 5? So what I want you to do is go and find the smallest, I don't need to say smallest, we basically, smallest exponent. We want to find the smallest exponent, and that x to the whatever exponent that is going to be your GCF here. Okay, so let's say, remember how we did GCF. So ignore this blank here. We're going to need more room than that. So let's do the GCF out front, x to the 4/5. Again, we're picking the one with the smallest fraction. And how do we factor out a GCF? Do you remember? We divided. Do you remember that? We brought down the expression x to the 4/5 plus x to the 11/5, and we divided by the GCF. Well, our GCF is x to the 4/5. Okay, let's simplify this and talk through this. So we're bringing down x to the 4/5. And x to the 4/5 over x to the 4/5, I want you to think about this the same as if you had x over x. X over x would all cancel out. And it's not just going to all cancel out. It's going to cancel to what? If you had a 1 in front, what's 1 divided by 1? It's just 1. It's not 0. Don't say it's 0. Okay? It doesn't cancel to 0. You do have a 1 there, but everything cancels to 1. Okay? So that's really what's happening there. Plus, how do we do this? Well, we learned this. We just learned this. So I want you to take your calculator and remember the quotient rule. The quotient rule is top minus bottom. So you're going to do in the calculator 11/5 minus 4/5 and see what you get. So this is going to be x to the 7/5. And this will be our fully factored form by factoring out the greatest common factor, our GCF, okay? You can do that even when our exponents are fractions. I know it's kind of weird, but we just did it, okay? So we're using our quotient rule to help with that. Let's look at our next example. So kind of doing the exact same thing. First convert, so we're converting y, or the cube root of y to the 13th, into y to the 13 over 3 plus the cube root of y to the 7th into y raised to the 7 over 3. Okay, which one's smaller here? That exponent of 7/3 is smaller than 13/3. Okay, obviously. So our GCF here is going to be y to the 7/3. And we're dividing. So y to the 13/3 divided by y to the 7/3 plus y to the 7/3 divided by y to the 7/3. Simplify. Y to the 7/3 times, do the subtraction. This is going to be y, top exponent minus bottom exponent. So 13/3 minus 7/3. Okay, that gives us 2. That's kind of nice. Why is it 2? Because 6 over 3, 13 minus 7 is 6. 6 over 3 is 2. All right, plus, what is y to the 7/3 over y to the 7/3? Well, let me think of this differently. What is 7/3 minus 7/3? It's 0. What is anything to the 0 power? It's 1. Remember that math rule? I know y'all didn't like it, but it is. So y to the 0 is 1. And that's our answer for that one. Lastly, we have a more complicated expression. Don't freak out yet. I want you to think about how we did this a few problems back. It doesn't matter what's underneath. I want you to consider that all as one thing. So this next one, we've got the square root of x plus 1 plus the square root of x plus 1 cubed. I want you to consider this as x plus 1 to the first. Let's convert this. We've got the square root. No, we don't. We're converting this. I just said that. This is x plus 1. What is our exponent inside? 1. What is our index? Understood 2. Okay, so this is x plus 1 to the 1/2. Plus, this is going to be x plus 1. What is our exponent inside? It's 3. And what is our understood index? Well, that's 2 because it's just understood that to be there. Okay, out of these two expressions, which one has the smallest exponent? It's the 1/2 instead of 3/2. So I want you to take the x plus 1 to the 1/2, put it out front, and we're going to write this whole thing out. All of this, x plus 1 to the 1/2, is going to be divided by x plus 1 to the 1/2, plus x plus 1 to the 3/2 is going to be divided by x plus 1 to the 1/2. So just whatever we put out front, that's what we're dividing by. Just did that the previous 2 times. And when we did GCF. Let's simplify this. Bring this down. That's going to be x plus 1 to the 1/2. X plus 1 to the 1/2 divided by x plus 1 to the 1/2 is the same way as saying y to the 7/3 divided by y to the 7/3. Or x to the 4/5 divided by x to the 4/5. It's the same on top and same on bottom. Those cancel out, but what do they cancel to? 1. Plus x plus 1 to what power? Well, we're still subtracting here. 3/2 minus 1/2. So what is 3/2 minus 1/2? Well, if you do that in the calculator, you're going to get 2/2. And 2 divided by 2 is 1. We'll simplify that in the next step. So this is going to be x plus 1 to the 1/2 times 1 plus, do I need this 1? No, so we're going to just take off the parentheses. X plus 1. And lastly, x plus 1 to the 1/2 times, add like terms. So it's kind of weird that you can do this here, but it's cool. 1 plus 1 is 2. So we're going to write this as x plus 2. And now it's fully factored, and that's our final answer, which I think is super cool.